All right. Okay, I guess I have to reset this one. So this one as well. All right. So hello everyone. Today is my day 5 of unemployment. So I would say laying off is tough. Being laid off is tough, and also for the immigrants, like for those on the H-1B visa, we only have like 60 days to secure another job, which is super brutal. But I don't know. I guess I have no other choice. I mean, just keep pushing. So here we are for today's 5 questions. So the first question is the 2 sum 2, and so the input array is sorted. So this one is the 2 sum, but the difference is it gives you the sorted array, and also they have the index starting from 1 instead of 0. So that's the tricky part for this question. And so it has a constraint that we can only use constant space. So O of 1 space complexity. So which means we cannot just use like a hash map or dictionary to save all the index and the elements. So so in this question we will use 2 pointers. So one starting from the left and one starting from the right, and we just see if these 2 numbers, since it's sorted, so the first would be 2 plus 15 is 17, so which is it's larger than the target. So we would move our right pointer, shift it to the 11, and 11 plus 2 is 13, still larger than the target. We keep moving our right pointer until we reach 7, 2.7. 2 plus 7 means equals to 9, and which gives us the answer. So it's like if it's less than the target, it moves the left pointer. If it's larger than the target, it moves the right pointer. So that way we don't have to have the store our store the index into our dictionary. So yeah, so this one is straightforward, and let's just write the code. So starting from 0, write these to length of numbers. Okay, and we also need I think we don't need the late, we can just return it, right? So for the 2 pointers question, we can always use the while loop. While left pointer is less than right pointer, then we want to get the sum, right? So the 2 sum would be numbers of L plus numbers of right, and we will check if this one is less than the target, then if it's less than the target means we have to move the left pointer. So left pointer will increment by 1, and else if the 2 sum is larger than the target means we have to decrement our right pointer. And if none of these satisfy means we equals to the target, that means we find the solution. So we just return the L plus 1 and also the right index plus 1. Since this question, the index starting from 1 instead of 0, so we have to plus 1 here. So yeah, this is the code. So let's run it. Did I spell something wrong? Oh, sorry. It's like we have to minus 1. So yeah, because it's index start from 0. Okay, so now it's passed, and we can submit it. See if it works. Okay, so it works. So for the time complexity, it should be big of n, since it's only scanned the array once, a list once. And for the space, it's constant time because we didn't store any dictionary, so we don't use any dictionary for saving the index. So it's constant time space. Okay, I think I need to open like otherwise I can. Okay, yeah, because yesterday I realized somebody is watching my stream and there's some chat. I just missed it. Then after I finished the stream, I realized, oh, there's somebody is giving me advice. So yeah, if I'm getting stuck or any, I'm making some mistake, you can just let me know. Help me. All right, so the next question is 3-sum. So this one is basically like a 2-sum-2 like extension. So so basically this question asks you, like, we have to find all the combination that sums to 0. So in this case, -1, -1, 2, which is -1, -1, and 2. This sums to 0, so which is the answer, and this one is -1, 0, 1. So also it has a constraint that the solution must not contain any duplicates, triplets, so it can only appears once. So for example, like if you have like 0, 0, 0, we can only return like 0, 0, 0. We cannot return 2, 0, 0, 0 because they are the duplicates. So so yeah, so this question 3-sum, basically we will have to sort the array first. So so for this one, we have to sort the array first. Then the array would looks like -1, -1, okay, and also a -4 at the beginning, and 0, 1, 2. We will turn this. We will sort it first. Then we will have like a 3-pointer, but basically we will sort it, which is the time complexity would be big O of n log n, because it's like a quick sort in Python. And then we would go over the list, so we will have like a first pointer, and we will check every. Then the question becomes like the 2-sum-2. So we will have this number, and which of these two numbers sums to the opposite of this number, which make it 0. And then we transfer our question back to the 2-sum-2 we just solved, and we have to iterate for every element in the list. So starting from, so we would have like like a left pointer and the mid pointer and the right pointer. So the left pointer will go over the list, and for each list we just keep checking if the mid pointer and the right pointer, if it sum up to the opposite of the left pointer pointing to. And we also have to make sure it's not duplicates. So one way to check if it's duplicates, we just need to check if when we switching our left pointer, we will have to see if the first element has been searched before. So for this -1 has been searched. For the rest, like the combination will definitely has duplicates. So if we saw like 2 elements are the same, we just skip one and we just keep moving and until the next one is different. So that will ensure we don't have any duplicates. So, and since we are going to scan it like twice, because we have to move the left pointer once, and each iteration we will have 2 pointers inside. So it's like n square of time complexity. So this question would become like this. This is the time complexity, and which just simplify to big N square. So so yeah, I think the code is more easy to understand. Let's just write the code and I can explain. So so first, I think we need to have a list to have our result stored. Then we have to sort it. So Python is easy. Just sort it. So now we have the array sorted. We are going to iterate through the array for in enumerate. I can spell enumerate. Okay. Nums, right? And we need to check if I is larger than 0, and the A is equals to the nums of I minus 1. So in this case means like we are changing the first the left pointer, or I don't know how to say it, the I pointer, and we want to make sure it doesn't has any duplicate. So if it does happen, we just continue, we skip it, and we goes to the next element, and from here we can initialize our left and right pointer. So so our left pointer would be I plus 1, and right pointer would be length of nums minus 1. All right, and then we convert our problem back to the toSum2. So so while left is less than right, we just have to sum it, right? Because we want to see if there's any satisfied set. So to right, and if 3 sum is larger than 0, right, means we have to move our right pointer. So right pointer would and else if 3 sum is less than 0 means we have to increment our left pointer, right? And else means we found the solution, so we append it. So dot append we have to append the number, right? It's not the index, we're going to append the number of it. So yeah. Okay, like this. Okay, and what else? And if it does found the answer, we will also have to check if the left pointer, when we move to the left pointer, is it the same? Because if it's the same, then we're going to keep moving our left pointer. So because if it's the same for the next one, it's going to have the same combination. So while L, not L, like nums of L is, so I probably should write this and nums of L plus 1. So we just keep incremented until it's not equal, so we eliminate all the combination. And after all this, we can return the result. So yeah, so basically this is like an advanced of 2 sum 2 we just solved. Let's run it, hope it works. Oh, of course, that's, you have to write it, comment it out. Did I? Oh, okay. So in here, since you find the solution, you will need to increment your left pointer once. Otherwise, it just keep running. So yeah, be careful. Okay, so yeah, since every time we find like a solution, like this is the first one, and like if you find this solution, you move your left pointer, increment it by 1, and you also want to check if the next one is the same. So if it's the same, we keep moving our left pointer. So to make sure we don't have any combination is duplicates. Okay, let's submit it. Okay, so I guess I have some missing stuff. Oh, I think it's -1. It's not like +1, should be -1. So since we already moved our left pointer, so we want to check if the moved pointer is equals to the previous one, right? So it's like since we incremented 1 by here, so we have to minus 1 too. So this is the one we just executed, and this is the one is the next one. And if it's the same, so it duplicates, then so let's submit it again. All right, so it got passed. So for the time complexity for this one is n squared, and the space complexity should be 1 because we didn't have store any, or probably this one we stored big O of n, so we might have n elements in it, less than n, but it's n. Okay. All right, so and the next question is the container with most water, and this question also a typical 2-pointer question. So we just have the left pointer and right pointer, and the formula would be how to calculate the container with the most can contain the most water, which is whoever left and right, which is take the minimum of it and we times the length of it. So that's where we will get the how many water it can contains, and we just initialize the result and we just keep updating when we move shifting the pointer. So that way we can guarantee we find the solution. So and how do we choose which pointer is to move? Because we want to find with the most we want to find the container that we can contain most water. So we will move whenever the pointer is lower. So for example, for this case, we will move if starting from left pointer and right pointer. We will first calculate it's 1 times like 1, 2, 3, 4, 5, 6, 7, 8. So the first container would be just 8, right? And since the left pointer is less than the right pointer, we move the left pointer. So now here is 8. We just 8 and with 7. So 7 is less than 8, so it's 7 times 7, which gives us 49. So this is the answer. And since this pointer now is smaller, we move this pointer to the left and we calculate this. So it's 3 times 6 is 18, so which didn't update our max result. Then we keep moving our right pointer, so now goes to the 8 again. So it's 8 and 8, so 8 just times 1, 2, 3, 4, 5, so just times 3 is just times 5, which is 40, and still not the max. And since they are the same length, we just move either one should be work, because we don't know, but in the end we will make sure we have every combination of the container. So it's the similar structure. Just have to write it out. All right. So we also need to have result is to 0, right? And we just remember the max area is equals to whichever is the mean of height left, height right, and we just times the right minus left, right? So this one will give us the max value, and we would update our result with max of max area and result. All right, so and if so we would move the whichever is smaller, the pointer. We'll move the pointer on the side which is smaller, has smaller value, so it will increase. So left is larger than right. We just increment. We just move our right pointer, and else we just move our left pointer. So it's yeah. So that's how we move our pointers, and after all this, we should get all the result being updated, so we can return our result. Yeah, so this should be the code. Okay, so it's passed. So for the time complexity for this one, since it's one pass, just big O of n. And for the space complexity, which is we don't store any dictionary or list, so which is just constant time, and submit it. All right. The fourth question would be trapping the rainwater. So this question is pretty hard. I think it's asked by Google, and I don't quite really understand this question. Basically, you will have to have like a left max and right max, and for each index, we would see the formula would be like you would take the mean of left max and right max. I probably should do the same style. Okay, and then we would minus the current height at index I. So this is how you know like how many water you can contain. So for example, this one, the left max is 1 and the right max is 2, and we take the minimum, which is 1, and 1 minus the height of index here is 0, so 1 minus 0 is equals to 1. So we append this to our result. So, and also in here, for example, the left max is 2, and for the right max is 3, and we take the minimum of it, which is 2, and 2 minus the current height of this one, so it's 1. So here we can only contain 1 water, and we append it, and this one is also followed, but this one is minus 0, so we have 2 because the left max is 2 and right max is 3. We take the minimum and we sum this up. So so basically you can have like 3 array, but there's a clever way is using 2 pointers, and it just keep updating the pointer. So there's some trick there, but I don't think I can finish this question just by seeing it. I probably have to memorize some of it. I highly recommend you go to the solution. There's one guy, he made the not this one. Yeah, something like this. So left max, right max, this is just what I said. And there is a more clearer way. I think I just, yeah, 2-pointer, this one. So I don't know whoever came up with this one is, I think it's crackhead. But anyways, highly recommend to see or check out the LeetCode video. I probably can see if I could I would just see so if not equals to, if not height, we just return 0 this case, and we initialize our left pointer to 0, right pointer to length, height, right, of course -1, and we also have to have a result to store all the water. So then while left is less than right, so what how do we choose which pointer to move is like, if left max is less than right max, we move the left pointer. So since we are getting the minimum of it, right? So we move whichever is has the smallest value. So if left max is less than right max, we move the left pointer. So so if and also we all have to define our left max here. So if it's less than it, we just increment by 1. And there's a special trick. So since there will be a case that is, since we are going to append it to the result, so which would be left max minus height of L. So since we are taking the minimum of it, since it's already left max already less than right max, so this would be the minimum and just minus the current height, and we can append it to the result. But sometimes the height of it would be larger than the left max, which could lead it to negative number. So here you will have to, you can use this trick, just get the max of left max and this one. So that's where you make sure left max always larger than the height L. So which will not give you the 0, less than the value less than 0. Otherwise you might have to check if this is 0. You can probably like something like this, right? So max something like this to make sure this is not the 0. I'm not sure if I could I'm not sure if I could do this. Let's try it out. I think there might have some issues. If not, height. Okay, so apparently I will have to increment I will have to get the left max updated. So all right, and also we need to update our, yeah, because if I write it this way, I didn't update the left max and right max. Probably GBR. Okay, I know this definitely works, but I just want to know if this one works. Right, let's run this. Yeah, this one works. So I think this way is more close to the explanation from leetcode, but he made a special trick is to put it in front of this line. So to make sure there is no zero in this case, I can show you like this one. You can basically, yeah, yep. So either way, I probably keep the old one like this. Submit it. Okay, so since we are using 2 pointers, so this the time complexity should be big of n, and for the space capacity we didn't store any array or list or dictionary, so it should be constant time. So that's for this question. Again, I'm really bad at explain this. I think leetcode did a better job at visualize it. So check out his video. And the last question is the best time to buy and sell stock. So for this one, it's a sliding window question. So we just have a window that we would keep expanded. So this question is asks you, it gives you an array, what would be the best time to buy and sell. So for example, the best way to buy is on day 2 is 1, and we sell on the day 5, 6, we get a profit of 5. So basically this window gives you the most profit. So initially we just keep looping, the window just keep growing as long as the starting point is less than the end of the window. We move our left pointer to the next to the end of the window. So 7 is larger than 1, so there's no way 7 can be the start. So we move our 1 as a start, then we go to 5. The profit is 4, so now it's acceptable, so we keep moving. So now it's 3, So 3 minus 1 is 2, which still less than 4, but it's okay, it's allowed. So we just keep moving. And we go to 6 minus 1 is 5, so which gives us the largest output. So we keep moving. We update our list result, and we keep moving. And it's 4, and 4 minus 1 is 3, and this is less than the 6 minus 1 is 5. So this ends the search. Then we return 5. So so yeah, so that's the trick. So whenever it's the left is larger than the right, we move the left. So we can start by left to 0, right is to 1. So that way we can. So if we want to check if length of prices is equal to 1, we just return 0 because there's no way you can get any profit. So yeah, then with that, write the while loop, while left pointer less than right pointer, and also have to initiate the result. So it's 0 at the beginning, or we can call it max profit. That's profit, more clear. So so if maybe I can do this way. So as long as the right pointer is larger than left pointer, we would just update it with right, and we keep moving our right pointer, right? So it's incremented by 1, and if it's not, means it's less than or equals, then we shift our left pointer. So to right, and right plus one. Okay, so we shift our left point, the window shift, and we also increment our the next for the window. So after this, we can just return max profit. Okay, so should be it. Of course, that's why you shouldn't change in the variable name while you are writing the code. Okay. Or maybe we don't need this, because there would be case like the left pointer is here, but the right pointer plus 1 is out of index. So yeah. Not sure if it works. Run answer. Great. What did I miss? Oh. So I'm not sure if I should use while loop here. Okay, so I think as long as the right pointer is less than the length of crisis, we should stop. Right? Okay. Okay, I guess I did something wrong. Not sure if I'm doing it right. Okay, so no matter what, no matter we find the solution, or no matter if the right is larger than the left or left is larger than the right, we all need to move the left point. We need to move the left point. If it failed, which means left is larger than the right, we need to move the left, and also we need to move the right. And if not, we just keep moving the right. So that's why no matter what, you need to move the right pointer. Or I think we can also put it in here, maybe. I think it's the same, right? So we can write last line of code. Yep. So so yeah, so this is the trick. Submit it. So I think it's like since it's like a sliding window, so it's only scan the whole the. It's possible that it's like is it like possible that it's scanning twice? I'm not sure because they say it's like 3 and 1 or so 9, 8, 7, something like this. So if it's less, then it keeps moving, right? And the worst case scenario would be like the profit just goes ons and ons and ons, right? So it's all valid, but you kind of have to loop loop it twice. So I think it's big O of n squared for the runtime complexity, the worst case scenario. And since we are storage any variables in list, so it's constant time. So oh wait, is this wrong? I thought I passed all the tested. No way. I think it's the same, right? I mean, there must be some cases. Okay, so what happened? So it should be 1 in this case. Okay, so we don't need the since it's less, it's not include the length, or I can write it in this way as well. I think this should also working. It's the same because we are allowed right pointer to the end. So either way. All right, so that's it for today's 5 questions. I don't know. I feel it's so tired. I don't understand how people really can keep doing it every day and took it as a hobby. But I do see myself improving like many of these questions. Like at the very beginning, it will be I'm having problem to really to write it out. So right now I feel like I can transfer my thought into the code, and I'm being able to like troubleshooting, even though there's some memorization to the question. So to be clear, all these questions I've done it at least once in the morning. So it's kind of cheating because there's no way you would know the interview question might just change, right? So so yeah, and even this, I've done this before, I still make mistakes. Like I don't remember, but every question I think I made some minor mistakes. But I guess that's the trick, right? You got to keep practicing and until you get really good at it. So yeah, that's for today's video. I don't know how you guys think, and also let me know if your company has like entry level general software engineer. Please let me know. I can write Python, I can write Java, a little bit JavaScript. Like I only do like full stack web development bootcamp on Udemy, but I haven't been practice it for a while, and I have some machine learning project during the past, like for the time series data. I'm using like decision tree or like the long short-term memory, LSTM, and what else? Also like auto regression. Like what kind of machine learning model I've made. I also have some experience in computer vision. I don't know. I tried so many different things, and now I feel like it's like I have some experience. Like I do like Java. I do know like how to do like a basic Android app, and know how to do like a basic HTML, CS, and JavaScript website. And also I have some game development experience. Also I have some machine learning experience, and but all of them I feel like it's like a toy project from the school. So Probably it's not like super competitive in today's market. So I'm thinking to I have to choose a track basically. I think in today's market, I think right now I'm focusing on like a new grade role, so like general software engineer, and I can just have some training while I on board. I can pick up the language pretty fast and to see what's the stack that the company is using, and I think that's the sweet spot for me. But I know the market has been tough right now, so like if I go to like linking right now, right, and let's say the job, and yeah, like oh, they got some openings from Amazon. That's good. Let's apply in them all, I guess. Yeah, it didn't hurt to apply, but right now the market is really tough. It's really tough. Like I don't know if I could get any interview of it. Yeah, right now they ask you for like 3 years non-internship like experience. So this is not like an entry-level job, but I have no choice, right? Less than 1 year, yes. I think 2 years, yes. And I do need sponsorship. No. Continue. And yeah, let's see what's the current which resume I'm using. Okay, I guess I probably should replace it. Browse file. I think. Yeah, I think it's the same one. Save and continue. Alright, let's submit it. Yup. Yeah, happy. Alright, anyways, what are we? Where are we? Like for this one, like backend Java, 3 to 5 years. I do have 3 to 5 years working experience, but not like crazy. Like I'm not doing it for my everyday job. I do have some development, but just not like very intense. So yeah, I've been applying for like everywhere, and let's see, it's just 1 day ago, it's over 100. Let's see how many. 357 in just 1 day, right? And 144, they are like senior level. So I don't know, this is the market, and it's crazy. It's just like everyone is trying to get into tech, but it's hard. Yeah, you have experience solving full stack machine learning problems. Seriously, NLP is just software developer engineer 2. How many 8 applicants. Okay, I'm going to apply this one. Apply. Okay, the fun part. Of course, do not match. All right, so okay, great. Just went freezing. It's just frozen. I don't know. Can I just do other? Whatever. No. Is my internet slow or am I just streaming, you know? If that's the case. I don't want to keep, you know, just applying. Can somebody help me? What happened? Continue. Can I refresh it? Great. How many times I have to do it? Other. No. No. Yes. Yes. I don't know how much I need to spend in LA. Like, no. Of course no. Seriously, I wish. No. Oh my god. Is it just slow? It strains my soul. Like the job hunting, you know. It's like, I don't know if it's. Does it really matter? Or am I just wasting my time? But I guess I don't have any choice. I'm just renting by myself. I really wish I have someone, you know, just to talk to. Yeah, and today I make a LinkedIn post, so hope there will be some recruiter seeing it, but I guess they are all too busy. Yeah, I cannot imagine, like, you have to review like thousands of resume just for one position, you know, the chances are like 0.1, less than 0.1%. How could you stand out, right? How could you stand out? All right, let's pray. Let's pray. You just apply and pray. Apply and pray. Apply and pray. Right, and also let me know how you search jobs, right? Probably Python, that's my main language. I don't know how companies building, what's their stack. I know it's mainly for like a data science basically, but it's just 24 hours. Let's make it quick, right? If it's not, we have to keep moving. So, all right. So, let's see. 6 months contract, right? Okay. It's not so bad. Right, I'm in. Alright, I think today I kind of have to separate my resume. So I think I probably should like make a copy of it, right? And we just rename it maybe MLE, right? And then we can have SDE general. Oh, I'm so hungry. I need to get something to eat. I don't know. It's just so draining. I think I can probably make I don't know, like a game dev. Just game, I think it's fine, right? Just game. So, what would be the best chance? I think this one, right? Okay, so since my internet is slow today. All right, software. Okay. I don't really have something to quantify the impact. I think that's it's like beautiful it's called data plumbing, right? Streamline the data pipeline. Collide. Beautiful soup. Is it beautiful soup? So this one, okay. I think streamline data pipeline is it's okay. There is also another library called Syndom. It's not just for the data, it's not just for the invoice, it has many things. any dictionary, so we don't use any dictionary for saving the index. So it's constant time space.
Yes. Hi, in this video we're going to talk about network data. We've got to give the button text some ideas, so end. Service. It's sort of a database access object, but it's really for
via a REST API. Great, so let's jump into what exactly a REST API is. So RESTful web service, right? That's a service that uses stream methods or operations. Right? So what's the equivalent of create in a HTTP method? Well, it's post. And how about read? So read is actually called get. Update or replace is put. And delete, guess what it is? Delete. Not too creative there. So how about a request itself? What are some of the pieces of it? So first of all, you might have an operation. That's kind of what we just talked about here with the HTTP methods. You might have an endpoint, which is what we just talked about over here. This is your REST API endpoint. Right? So we want to get the flavors that up, flavor of chocolate. In response, we see
Oh, I need to rest. Alright, call it a night. See you guys.